Hello, in this lecture we will answer on two questions. In the first question, we will find out the blue area, and in the second question, we will find out the radius of this circle that blocks triangle ABC. So we start with the first question. In the first question, we have the big circle, and the triangle ABC is described by the big circle, and the AB is the diameter of the big circle, and the small circle is described by triangle ABC. The radius of the small circle equals to 4 units, and the radius of the big circle equals to 13 units. And we want to find out the blue area, or the area of the blue shape. So first of all, we will define the center of the small circle as O. And we will define the point of tendency B with the small circle as M. We will define the point of tendency of tangent AC with the small circle as N. And we will define the point of tendency of tangent AB with the small circle as L. Okay. In the next step, we will join points O and N together by a straight line. And we will join points O and N together by a straight line. O is the center of the small circle. N is a point on the small circle itself, so this is exactly the definition of a radius. So ON is the radius of the small circle. We will define the radius of the small circle as small r, and we know that the radius of the small circle equals to 4 units. Likewise, OM is also the radius of the small circle that is equal to 4 units. And we also have rule number 1, and according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency B in the small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Likewise, we have the radius ON. This is drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So if AC is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we also have the rule that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So here peripheral angle ACB, this angle rests on the diameter of the big circle that is AB, therefore angle ACB must be equal to 90 degrees according to the rule that I mentioned. So actually, quadrilateral ONCM has three right angles. One, two, three right angles. And the sum of three right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle MON. In total, the sum of those four angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation and we get that the missing angle, angle MON, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So angle MON equals to 90 degrees. Actually, we found out that inside quadrilateral MOCM and OCM we have four right angles. And any quadrilateral that has four right angles must be at least a rectangle if not a square. So we relate to quadrilateral NOCM as a rectangle. Okay. Quadrilateral NOCM is a rectangle. And we have the rule that the opposite sides of a rectangle are equal to each other. So here, the opposite sides of rectangle NOCM, they are equal to each other. That is to say, NO equals to CM. NO equals to CM. NO equals to CM. But we have already found out that NO equals to 4 units. This is the radius of the small circle. So NO equals to 4 units. And from this equation, 4 equals to NO equals to CM. We will derive that CM is also equals to 4 units. Okay, CM is also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will conclude that OM equals to NC. OM equals to NC. But OM equals to 4 units, it is the radius of the small circle. So we can write down that OM equals to 4 units, And from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. NC equals to 4 units. NC equals to 4 units. In the next step, we will define side AC of triangle ABC as A. So here, AC equals to A according to our definition. We define side CB as B, BC equals to B, also according to our definition. And we define side AB as C. AB equals to C, also according to our definition. So what is the length of line segment AN? From the drawing, it is very easy to see that AN equals to AC minus NC. Again, AC minus NC equals to AN. AC minus NC. So AN equals to AC equals to A according to our definition, minus NC. NC equals to 4 units according to what we have already found out. So in conclusion, we found out that AN equals to A minus 4. Likewise, we find out the length of line segment MB. The length of line segment MB equals to CB minus CM. CB minus CM equals to CB minus CM equals to MB. So MB equals to CB. CB is B according to our definition, minus CM. CM equals to 4 according to what we have already found out. So in conclusion, we found out that MB equals to B minus 4. In the next step, I will present to you rule number 2. According to rule number 2, a tangent to a circle, according to rule number 2, the lengths of two tangents from a common start point to a circle are equal. I repeat again. the lengths of two tangents from a common external point to a circle are equal. So we focus on the common external point, point A. From the common external point, point A, we have two tangents to the small circle. The first tangent is tangent AN, and the second tangent is tangent AN. And according to rule number 2, they are equal to each other. So here AN equals to AN according to rule number 2. And we have already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation, AN equals to A minus 4, we will derive that AN is also equals to A minus 4. AN equals to A minus 4. So here, AN equals to A minus 4. So in the next step, we'll focus on the common external point, point B. Here we'll focus on this common external point, point B. From the common external point, point B, we have two tangents to the small circle. The first tangent is BL and the second tangent is BM, and according to rule number 2, they are equal to each other. So here BL equals to BM according to rule number 2. But we have already found out that Bm equals to B minus 4. So we can write down that Bm equals to B minus 4. And from this equation, Bn equals to Bm equals to B minus 4, we derive that Bn is also equals to B minus 4. Bn equals to B minus 4. So in conclusion, we found out that Bn equals to B minus 4 and An equals to A minus 4. Okay, so in the next step, we'll focus on the right triangle ABC. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared. And it must be equal to the sum of the squares of the perpendiculars. This is to say, it must be equal to AC squared plus BC squared. So in the right triangle ABC, by PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to AC square plus BC square. AB equals to C, so AB square is C square, and it is equal to AC square. AC equals to A, so AC square is A square plus BC square. BC equals to B, so BC square is B square. So in conclusion, we found out that according to equation number 2, C square equals to A square plus B square. But actually AB is the diameter of the big circle that is equal to C, but the diameter of any circle is twice as long as the radius, so if the radius of the big circle equals to capital R, then the diameter will be equal to 2 times capital R, and it is given us in the question that capital R, the radius of the big circle, equals to 13 units. Therefore, 2 times capital R is 2 times 13, that is 26. So actually we found out that C equals to 26, so we substitute C by 26 and we get that C square is 26 square, 26 square is 676, that is equal to A square plus B square. So according to equation number 2, we found out that A square plus B square equals to 676. But according to equation number 1, here actually what is the length of AB? From one side, AB equals to 26 units. But from the other side, AB equals to AL plus LB. Again, AB equals to AL plus LB. So AB equals to AL plus LB, AL, so AL equals to A minus 4, so we substitute AL by A minus 4, and LB equals to B minus 4, so we substitute LB by B minus 4. So in conclusion, we found out that according to equation number 1, 26 equals to A plus B, minus 4 plus minus 4 is minus 8. So here we will add 8 to this equation, equation number 1, and we get that 26 plus 4 is 34. 34 equals to A plus B. So according to equation number 1, we found out that A plus B equals to 34. So here we will square both sides of this equation, equation number 1. And we found that according to equation number 1, a plus b squared equals to a squared plus b squared plus 2 times ab, and it is equal to 34 squared. 34 squared equals to 1156. So according to equation number 1, we found out that a squared plus b squared plus 2 times ab equals to 1156. But according to equation number 2, a squared plus b squared equals to 676. That is to say, we can substitute a squared plus b squared in equation number 1 by 676. So we'll do it now, and we'll get that according to equation number 1, a squared plus b squared is 676 plus 2 times ab equals to 1156. So here we subtract 676 from this equation number 1, and we get that according to equation number 1, 2 times AB equals to 1156 minus 676 equals to 480. So we found out that according to equation number 1, 2 times AB equals to 480. Here we divide this equation number 1 by 2, and we get that a times b equals to 480 over 2 is 240. So here ab equals to 240, we divide this equation by 2, and we get that according to equation number 1, ab over 2 equals to 240 over 2. 240 over 2 is 120. In conclusion, we found out that according to equation number 1, AB over 2 equals to 120. So, what is actually the area of the blue shape? The area of the blue shape from the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So the area of the blue shape equals to the area of triangle ABC minus the area of the small circle, and the area of triangle ABC equals to the base of the triangle, that is AC, times the height to the base, that is CB, over 2. Repeat again. The area of triangle ABC equals to the base of the triangle, that is AC, times the height of the base, that is CB, over 2, minus the area of the small circle. The area of the small circle equals to pi r squared, and r equals to 4 units. So the area of triangle ABC equals to AC. AC is A times CB. CB is B, according to our definition, over 2. So the area of triangle ABC equals to AB over 2 minus the area of the small circle, that is pi r squared. R equals to 4. R equals to 4, so r squared is 4 squared, that is 16. So the area of the small circle equals to 16 pi. In conclusion, we found out that the area of the blue shape equals to a times b over 2 minus 16 pi. But we have already found out that a times b over 2 equals to 120. So we substitute ab over 2 by 120. So in conclusion, we found out that the area of the blue shape equals to 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. Okay. Now this blue shape equals to either 120 minus 16 pi, on terms of numbers, it is equal to 69.73 square units. So we finish with the first question. In the next step, I present to you the second question, and we will solve the second question with three different methods. So in the drawing we have here triangle ABC that is inscribed by this circle, and we know that the area of triangle ABC equals to 9 square units, side AB equals to 5 units, side BC equals to 6 units, and we want to find out the radius of this circle that blocks triangle ABC. So first of all, we'll start with the first method. From point A, we draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the point of tendency of the perpendicular from point A and BC as D. And we know that the area of triangle ABC equals to 9 square units. So I write it down. The area of triangle ABC equals to 9 square units. But we know also that the area of triangle ABC equals to the base of the triangle, that is BC, times the height of the base, that is AD, over 2. Okay. Now from ABC equals to also the base by BC times the height of the base, that is AD over 2. It is given as the question that BC equals to 6 units, so we substitute BC by 6, so it is 6 times AD over 2. And 6 over 2 is 3, so in conclusion we found out that, according to question number 1, 9 equals to, again 6 over 2 is 3, so 9 equals to 3 times AD. Here we divide this equation by 3, and we get that according to equation number 1, AD equals to 9 over 3 is 3. AD equals to 3 units. Here we found out that AD equals to 3 units. In the next step, we will focus on the right triangle, triangle ABD. On the right triangle, triangle ABD. By PT is the equation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse is AB. Therefore, the hypotenuse is AB squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD squared plus BD squared. AD squared plus BD squared. So I put again in the right triangle ABD, according to the Pythagoras theorem, AB squared equals to AD squared plus BD squared. AB equals to 5, so AB squared is 5 squared, that is 25. That is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus BD squared. So in conclusion, we found out that 25 equals to 9 plus BD squared. We subtract 9 from this equation number 2, and we get that 25 minus 9 is 16, so 16 equals to BD squared. We'll take a root out of this equation number 2, and we get that BD equals to the square root of 16, that is 4. So BD equals to 4 units. We can write down that BD equals to 4 units. And what is the length of line segment DC? From a drawing, it is very easy to see that the length of line segment DC, it is equal to BC minus BD. Again, BC minus BD equals to DC. BC minus BD. So DC equals to BC is 6 units, minus BD is 4 units. So in conclusion, DC equals to 6 minus 4, that is 2. So DC equals to 2 units. So DC equals to 2 units. In the next step, we will focus on the right triangle ADC. On the right triangle ADC, by Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AD, so the square of the hypotenuse is AD squared. That is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD squared plus DC squared. AD squared plus DC squared. So, found out that AD squared equals to the hypotenuse is AC, so it is actually the square of the hypotenuse is AC squared. So found out that AC squared equals to AD squared plus DC squared. So AC squared equals to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus DC squared. DC is 2, so DC squared is 2 squared, that is 4. So in conclusion, we found out that AC squared equals to 9 plus 3, that is 13. AC squared equals to 13 units. We will take a root out of this equation, and we get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. We can write here that AC equals to the square root of 13 units. In the next step, we will define the center of this circle as point O, and we will join points A and O together by a straight line. And then we'll extend AO by straight line until it touches the circle at this point. When we find the touching point of the extended AO and the circle is point E. So here we have chord AE that passes through the center of the circle, and any chord that passes through the center of the circle, it is defined as the diameter. So chord AE is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius, so if the radius of this circle equals to capital R, then the diameter AE will be equal to 2 times capital R. Okay? In the next step, we'll join points B and E together by a straight line. So we created here peripheral angle, angle ABE. Peripheral angle, angle ABE. Peripheral angle, angle ABE rests on the diameter of the circle that is AE, and any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. Therefore, peripheral angle ABE equals to 90 degrees. Okay? And we also have another rule that peripheral angles that rest on the same chord are equal to each other. Again, peripheral angles that rest on the same chord are equal to each other. So here we have those two angles, angle ACB and angle AEB. Those two peripheral angles, they both rest on the same chord that is called AB, therefore they are equal to each other. So I write it down. So this peripheral angle is angle ACB. And it is equal to this peripheral angle, angle AEB. Why? Because both of those peripheral angles rest on the same chord called AB. So if we define angle ACB as theta, here angle ACB equals to theta, then from this equation theta equals to angle ACB equals to angle AEB, we will derive that angle AEB is also equals to theta. Okay, angle AEB equals to theta. Yeah, this angle also equals to theta. So actually, in the right main triangle, triangle ABE, angle AEB equals to theta, angle ABE equals to 90 degrees. So this angle, angle BAE, must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle AB 280 degrees. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. And in triangle, the right triangle, triangle ADC, this angle equals to theta. We know that angle ACD equals to theta, this angle equals to 90 degrees, therefore, for the same reason exactly, this angle must be also equal to 90 degrees minus theta. So in the next step, we will prove that the two right green triangles are similar to each other. So the triangle AEB is similar to triangle ADC. So why those two triangles are similar to each other? So first of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually angle ABE equals to this angle that is actually angle ADC. And they are both equal to 90 degrees, therefore they are equal to each other. I'll repeat again. Angle AB equals to angle ADC equals to 90 degrees. In addition, we have those two angles that are both equal to theta, therefore they are equal to each other. So angle AEB equals to this angle that is actually angle ACD, and they are both equal to theta, therefore they are equal to each other. Repeat again, angle AEB equals to angle ACD equals to theta. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle EAB equals to angle DAC and they are both equal to 90 degrees minus theta, and therefore they are equal to each other. Repeat again, angle AEB equals to angle DAC equals to 90 degrees minus theta. So we actually proved that all three angles of triangle AEB can go to all three angles of triangle ADC. Therefore, triangle AEB is similar, this is the sign of similar, to triangle ADC according to angle similarity rule. Okay. And from the fact that those two real right triangles are similar to each other, we conclude that the following equation is true. We conclude that AB over AD equals to AE over AC. I'll repeat again. We conclude that AB over AD equals to AE over AC. Okay, so AB equals to 5 units, AD equals to 3 units, AE equals to 2 arms, is the diameter of the circle, and AC equals to the square root of 13 units. So in conclusion, according to equation number 3, we know that 5 over 3 equals to 2 over square root of 13 units. We will multiply this equation by square root of 13 units, and we will get that according to equation number 3, 5 over 3 times square root of 13 units equals to 2r. Here we divide this equation number 3 by 2, and we get that r, the radius of this circle that we are looking for, equals to either 5 over 6 times square root of 13 units, so in terms of numbers it is a little bit greater than 3 units. Okay, we finished with the first method. In the next step I will present to you the second method. In the second method we use all the things that we have already found out in the first method. So here from point A we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. We have already found out that AD equals to 3 units according to the first method, DC equals to 2 units, and DB equals to 4 units. According to the first method, we will extend side AD by a straight line until it touches the circle. At this point, we define the touching point of the extended AD and the circle is E. So in the next step I will present to you a new rule that is actually rule number 1. According to rule number 1, if you have this circle, and we have here chord AB. This is called AB. That intersects with chord CD. This is called CD, and the intersection point is at point O. So if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Okay, read again. If chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We actually can implement rule number 1 in our drawing, because in our drawing we have this circle, and inside this circle we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we will get that AD times DE, AD times DE equals to BD times DC. I repeat again. Because of the fact that chord AE intersects with chord BC at point D, then AD times DE equals to BD times DC. So AD is 4, AD is 3, AD is 3, DE is the missing 9 segment, so we leave it as it is. So it is 3 times DE, that is equal to BD, BD is 4, and DC is 2. So in conclusion, we found out that 3 times DE equals to 4 times 2 is 8. We divide this equation by 3, and we get that DE equals to 8 thirds. DE equals to 8 thirds, so here we can write down that DE equals to 8 over 3 units, and here we have AD is perpendicular to BC, therefore it is absolutely a straight line. Then we extended the straight line AD by a straight line, therefore the result that is AE must be also a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So AE is a straight line. If you focus on this side of the straight line AE at point D, then the sum of the angles here must be equal to 180 degrees. So 90 degrees plus this angle must be equal to 180 degrees. That is to say, this angle must be also equal to 90 degrees. In order to complete the sum of the angles on this side of the straight line DE to 180 degrees, this angle must be equal also to 90 degrees. Likewise, if you focus on this side of the straight line AE at point D, then the sum of the angles here must be equal to 180 degrees. We have here one angle that is equal to 90 degrees, plus this angle. In total they must be equal to 90 degrees. Therefore, the missing angle also must be equal to 90 degrees in order to complete the sum of the angles on this side of the straight line A at point D to 180 degrees. This angle must be also equal to 90 degrees. So we actually found out that all the angles around point D are right angles. In the next step, I will present to you rule number 2. According to rule number 2, we have this circle, and then we have chord AB. This is chord AB that intersects with chord CD. This is chord CD, and they intersect, and they create between them 90 degrees at the intersection point. So if the intersection point is at this point, point O, the angle that they create between them is 90 degrees. So all the angles around point O are equal to 90 degrees. Okay? So if chord AB intersects with chord CD at 90 degrees, then the following equation is true, that 4 times R squared equals to, if AO equals to A in its length, OB equals to B in its length, CO equals to C, and OD equals to D. So 4 times R squared equals to A squared plus B squared plus C squared plus D squared. R is the radius of the circle that contains the two chords. So 4 times R squared equals to A squared plus B squared plus C squared plus D squared. We actually can implement rule number 2 in our drawing, because in our drawing we have chord AE that intersects with chord BC at 90 degrees. Therefore, we get that according to equation number 2, 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. Okay, 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. So here 4 times R squared equals to BD squared. BD is 4, so BD squared is 4 squared, that is 16, plus DC squared. DC is 2, so DC squared is 2 squared, that is 4, plus AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus DE squared. DE is 8 thirds, so DE squared is 64 over 9. So in conclusion, we found out that 4 times r squared equals to 16 plus 9 plus 16 plus 4 plus 9 plus 64 over 9. So 16 plus 4 is 20 and 20 plus 9 is 29. So here we get that 4 times r squared equals to 29 plus 64 over 9. Here we multiply 29 by 9 and then we divide it by 9 in order to have a common factor with this expression. So here 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 325 over 9. So in conclusion, found out that 4 times r squared equals to 325 over 9. We divide this equation by 4 and we get that according to this equation, r squared equals to 325 over 9 times 4 is 36. 325 is 25 times 13 over 36. Here we take out of this equation and we get that the radius that we are looking for equals to either the square root of 25 is 5, the square root of 36 is 6, and here we have also square root of 14. So in conclusion, the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 14 units, so in terms of numbers, it is a little bit greater than 3 units. Okay, so we finish with the second method. The next step will present to you the third method. In the third method, we will define angle ABC as theta, and we have a special formula to find out the area of any triangle. So if we have here triangle ABC, that can be any triangle, this is triangle ABC, and we know that side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length, and the angle between side AB and side AC is theta. Then the area of this triangle, according to the new formula, the area of triangle ABC will be equal to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. So we find out the area for a triangle ABC according to the new formula. According to the new formula, the area of triangle ABC will be equal to AB times BC times sinus theta over 2. Okay, the area of this triangle is AB times BC times sinus theta over 2. But we know that the area of triangle ABC equals to 9 square units. It is given as the question. So 9 equals to AB. AB is 5, BC is 6 times sinus theta over 2. So here 9 equals to 5 times 6 is 30, and 30 over 2 is 15. So 9 equals to 15 times sinus theta. Here we divide this equation by 3, equation number 1 by 3, and we get that according to equation number 1, 15 over 3 is 5, so it is 5 sinus theta. That is equal to 9 over 3 is 3. So 5 sinus theta equals to 3. We divide this equation by 5, and we'll get that sinus theta equals to 3/5. Sinus theta equals to 3/5. But we also have the trigonometric identity that says that cosine theta equals to the square root of 1 minus sinus square theta. So here cosine theta equals to the square root of 1 minus sinus square theta. Sinus theta equals to 3/5, so sinus square theta will be equal to 9 over 25. So I found out that cosine theta equals to the square root of 1 minus 9 over 25. So cosine theta equals to, here we will substitute 1 by 25. We'll multiply 1 by 25, and then we will divide it by 25 in order to make common factor with this expression, and we'll get that here 25 minus 9 over 25. Cosine theta equals to 25 minus 9 over 25. So here cosine theta equals to the square root of 25 minus 9 is 16 over 25. So in conclusion, we found out that cosine theta equals to the square root of 16 is 4, and the square root of 25 is 5. So cosine theta in conclusion equals to 4/5. In the next step, I will present to you the law of cosines, and we will implement the law of cosines in our triangle ABC. So I've already presented to you the law of cosines in the past, so we'll do it quickly. The law of cosines. Actually, the law of cosines is true in any triangle. So if you have here a triangle ABC, that could be any triangle. This is triangle ABC. The angle between side AB and side AC is theta. The length of side AB is A units, the length of side AC is B units, and side BC equals to C units in its length. Then cosine theta will be equal to A square plus B square minus C square over 2 times A times B. Okay, here cosine theta in this triangle ABC equals to A square plus B square minus C square over 2 times A times B. We will implement the law of cosines in our triangle ABC. So according to the law of cosines in our triangle ABC, we get that triangle ABC cosine theta will be equal to AB square plus BC square minus AC square over 2 times AB times BC. Okay. Now of this triangle ABC, cosine theta here equals to AB square plus BC square minus AC square over 2 times AB times BC. We have already found out that cosine theta equals to 4/5, so we will substitute cosine theta by 4/5. and we get that 4/5 equals to AB squared. AB is 5, so AB squared is 5 squared, that is 25, plus BC squared. BC is 6, so BC squared is 6 squared, that is 36, minus AC squared over 2 times AB is 5 and BC is 6. So here we have found out that 4/5 equals to 25 plus 36 is 61, minus AC squared over 5 times 6 is 30, and 30 times 2 is 60. Here we multiply this equation by 16, we get that 60 over 5 is 12, and 12 times 4 is 48. So 48 equals to 61 minus AC squared. Okay. Here we will add to this equation AC squared and subtract 48 simultaneously, and we get that AC squared equals to 61 minus 48 is 13. Here we take a root out of this equation, and we get that AC equals to the square root of 13 units. So we found out that AC equals to the square root of 13 units. Here AC is the square root of 13 units. In the next step I will present to you a new formula that gives us the radius of any circle that is blocked by the radius of any circle that blocks a triangle inside it. So here we get that the radius of a circle that blocks a triangle will be equal to the multiplication of the sides of the triangle that is blocked by the circle. In this case, this is triangle ABC that is blocked by the circle, so it is AB times AC times BC, AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. So in this case, it is triangle ABC, so it is 4 times the area of triangle ABC. So the radius of a circle that blocks triangle ABC equals to the multiplication of the sides of the triangle over 4 times the area of that triangle that is blocked by the circle. So the radius of our circle that blocks triangle ABC will be equal to AB is 5, AC is equal to 13, and BC is 6 over 4 times the area of triangle ABC, and the area of triangle ABC equals to 9 square units, so according to what is given us in the question. So R equals to 5 times 6 is 30 times square root of 13 over 4 times 9 is 36. Here we divide both the numerator and the denominator on this side of the equation by 6, and we get that R, the radius that we are looking for, equals to 30 over 6 is 5 times square root of 13 over 36 over 6 is 6. So R either equals to 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, so we finished with the first method. In the next step, we'll summarize the lecture. We start with the first question. So in the first question, we have the big circle that blocks triangle ABC, and the triangle ABC itself blocks the small circle. The radius of the big circle equals to 13 units. The diameter of the big circle is AB, and the radius of the small circle is 4 units, and we want to find out the area of the blue shape. So first of all, we defined the center of the small circle as O. We define the point of tendency B with the small circle as M. We define the point of tendency of tangent AC with the small circle as N, and we define the point of tendency of tangent AB with the small circle as L. Then we join points O and M together by a straight line, and we join points O and N together by a straight line. Point O is the center of the circle, the center of the small circle. Point N is the point of the circle itself. This is exactly the definition of a radius. Therefore, ON is the radius of the small circle that is equal to 4 units. From the same reason, exactly OM is the radius of the small circle that is also equal to 4 units. So here we have the radius OM that is known to the point of tendency. And we have rule number 1 that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So whenever we have a radius that is drawn to the point of tendency, like here we have the radius OM that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Likewise, we have the radius ON that is drawn to the point of tendency. Therefore, tangent AC will be perpendicular to the radius NO. So if AC perpendicular to NO, it means that this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. And we also have the rule that any peripheral angle that rests on the diameter of a circle is equal to 90 degrees. So peripheral angle ACB that rests on the diameter of the circle equals to 90 degrees. Angle ACB equals to 90 degrees. So inside quadrilateral NCMO we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle that is actually angle MON. In total, the sum of those 4 angles must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle MON equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this angle is a right angle, so inside quadrilateral MOCN, we have 4 right angles, and any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to quadrilateral NOCM as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, NO equals to CM. NO equals to CM according to the rule that the opposite sides of a rectangle are equal to each other. But we have only found out that NO equals to 4 units, so we can write here that NO equals to 4, and from this equation 4 equals to NO equals to CM, we derive that CM is also equals to 4 units. Here, CM is also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that OM equals to NC. OM equals to NC, but we have only found out that OM equals to 4 units. This is the radius of the small circle. And from this equation 4 equals to OM equals to NC, we will derive that NC also equals to 4 units. NC equals to 4 units. So we actually found out that quadrilateral NOCM, it is not a rectangle but a square. Then we defined side AC as A, side CB as B, and side AB as C. Okay, and found out the length of side AN equals to AC minus NC. Again, AN equals to AC minus NC. AN equals to AC minus NC. AC equals to A, and NC equals to 4. So in conclusion, AN equals to Y minus 4. Likewise, we found out the length of side AB. Side MB, the length of line segment MB equals to CB minus MB. MB equals to CB minus MB, so MB equals to CB, that is B, minus CM, that is 4. So in conclusion, MB equals to B minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. So here we have the common external point, point A. From the common external point, point A, we have 2 tangents two tangents to the small circle, tangent AL and tangent AN, and according to rule number 2, they must be equal to each other. AL equals to AN according to rule number 2. But we have already found out that AN equals to A minus 4. Here we can write down that A equals to A minus 4 according to what we have already found out. And from this equation, AN equals to AN equals to A minus 4, we derive that AL is also equals to A minus 4. Here AN equals to A minus 4. Likewise, we focus on the common exam point B. From the common exam point B, we have two tangents to the small circle, tangent BL and tangent BM. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, BL equals to BM according to rule number 2. But we have only found out that BM equals to B minus 4. BM equals to B minus 4. So from this equation, BL equals to BM equals to B minus 4, we derive that BL is also equals to B minus 4. BL is also equals to B minus 4, so we conclude and found out that LB equals to B minus 4 and AN also equals to, and AN equals to B minus 4. Okay, then we focused on the right triangle ABC according to the Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to AC square plus CB square. AB square equals to AC square plus BC square. AB equals to C, so AB square is C square. That is equal to AC square plus CB square. AC equals to A, so AC square is A square. And CB equals to B, so CB square is B square. So in conclusion, we found out that according to equation number 2, C square equals to A square plus B square. The diameter AB equals to C according to our definition, and the diameter of any circle is twice as long as the radius. So if the radius of the big circle is R, then the diameter will be equal to 2R. It has given us the question that R equals to 13, so 2R is 26. So the diameter of the big circle equals to 26 units. And therefore, according to the question 2, we get that C square equals to A square plus B square. C is 26, so C square is 26 squared, that is 676. That is equal to A square plus B square. And because of the fact that A square plus B square equals to 676, we will substitute. But first of all, we have from one side the diameter AB equals to 26 units. But from the other side, the diameter AB equals to AL plus LB. And the diameter AB equals to AL plus LB. It is very easy to see it from the drawing. AL equals to A minus 4. LB equals to B minus 4. So AL is A minus 4 and LB is B minus 4. So in conclusion, 26 equals to A minus 4 plus B minus 4. That is to say, 26 equals to A plus B. Minus 4 plus minus 4 is minus 8. So 26 equals to A plus B minus 8. We added added 8 to this equation number 1, and we found out that 26 plus 8 is 34, and 34 equals to A plus B. We squared both sides of equation number 1, and we found out that A plus B square equals to 34 square. So here A plus B square equals to A square plus B square plus 2 times AB, and it is equal to 34 square. 34 square is 1156. Okay. Then we subtracted A square plus B square in equation number 1 by 676 from equation number 2. And we got that A square plus B square is 676 plus 2 times AB equals to 1156. Here we subtracted 676 from this equation number 1, and found out that 2 times AB equals to 1156 minus 676 is 480. So according to equation number 1, 2 times AB equals to 480. We divided this equation number 1 by 2, and found out that AB equals to 480 over 2 is 240. We divided equation number 1 by 2 again. So AB over 2 equals to 240 over 2. 240 over 2 is 120. So in conclusion, found out that AB over 2 equals to 120 according to equation number 1. So what is the area of the blue shape? The area of the blue shape equals to the area of triangle ABC minus the area of the small circle. Okay, so the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. The area of triangle ABC equals to the base of the triangle that is AC times the height to the base that is CB over 2. Minus the area of the small circle, the area of the small circle equals pi r square. So here AC equals to A and BC equals to B. So AC is A, BC is B. So the area of triangle ABC equals to AB over 2 minus the area of the small circle, R equals to 4 units, so R square is 4 square. And in conclusion, the area of the small circle equals to 4 squared is 16. In conclusion, the area of the small circle equals to 16 pi. So in conclusion, the area of the blue shape equals to the area of triangle ABC that is AB over 2 minus the area of the small circle that is 16 pi. But we have already found out that AB over 2 is 120, so we can substitute AB over 2 by 120. And in conclusion, we found out that the area of the small circle equals to 120 minus 16 pi square units. So in terms of numbers, it is equal to 69.73 square units. Okay, we finished here with the first question. Then I presented to you the second question, and we solved the second question in 3 different methods. In the second question, we have this circle that belongs to triangle ABC. The area of triangle ABC equals to 9 square units, AB equals to 5 units, BC equals to 6 units, and we want to find out the area of this circle that belongs to triangle ABC. So we know that the area of triangle ABC equals to 9 square units, and the area of triangle ABC also equals to the base of the triangle that is BC times the height to the base that is AD over 2. BC equals to 6, so it is 6 times AD over 2. 6 over 2 is 3, so in conclusion we found out that according to equation number 1, 9 equals to 3 times AD. We divided this equation number 1 by 3, and we found out that AD equals to 9 over 3 is 3. So here AD equals to 3 units. Then we focused on the right triangle ABD. According to the Pythagoras theorem on the right triangle ABD, AB square equals to BD square plus AD square. AB square equals to AD square plus BD square. AB is 5, so AB square is 5 square, that is 25. And it is equal to AD square. AD is 3, so AD square is 3 square, that is 9, plus BD square. Here we subtracted 9 from this equation number 2, and we found out that 25 minus 9 is 16. So 16 equals to BD square. We took out of this equation number 2, and found out that BD equals to 4 units. What is the length of DC? DC is equal to BC minus BD. DC equals to BC minus BD. BC equals to 6 units, BD equals to 4 units, so DC equals to 6 minus 4, that is 2. So here DC equals to 2 units. Then we focused on the right triangle ADC. We implemented the Pythagoras theorem on the right triangle ADC. So here AC square equals to AD square plus DC square. AC square equals to AD square plus DC square in the right triangle ADC. So AC square equals to AD square. AD is 3, so AD square is 3 square, that is 9, plus DC square. DC is 2, so DC square is 2 square, that is 9. So in conclusion, we found out that AC square equals to 9 plus 3, 9 plus 4. AC square equals to 9 plus 4, that is 13. So AC square equals to 13. We took out of this equation, and we got that AC equals to the square root of 13 units. AC equals to the square root of 13 units. Then we define the center of this circle as point O, and we join points A and O together by a straight line, and then we extended AO by a straight line until it touches the circle at point E. So AE passes through the center of the circle, therefore AE is defined as the diameter of this circle. Because any chord that passes through the center of the circle is defined as the diameter. So AE is the diameter of the circle, and the diameter of any circle is twice as long as the radius. So if the radius of the circle is capital R, then the diameter will be equal to 2 times capital R. So A equals to 2 times capital R, and then we join points B and D together by a straight line. Here we have the peripheral angle ACB that rests on the diameter of the circle that is AE, therefore it is equal to 90 degrees. Any peripheral angle that rests on the diameter equals to 90 degrees, therefore peripheral angle ABE that rests on the diameter equals to 90 degrees. Then I presented to you also another rule, that peripheral angles that rest on the same chord are equal to each other. Those two peripheral angles, they are equal to each other because they rest on the same chord that is called AB. So here, peripheral angle ACB equals to peripheral angle AB because of the fact that both those two peripheral angles rest on the same chord. So if we define angle ACB as theta, then from this equation angle theta equals to angle ACB equals to angle AB, we will derive that angle AEB also equals to theta. This angle also equals to theta. So this angle equals to theta, this angle equals to 90 degrees, this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle AB to 280 degrees. This angle must be equal to 90 degrees minus theta. Okay, so, and here this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. Then we prove that the two green right triangles are similar to each other. Why? First of all, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Those two angles are both equal to 90 degrees, therefore they are equal to each other. And those two angles are both equal to theta, therefore they are equal to each other. So all the angles of triangle AB can go to the angles of triangle ADC. Therefore triangle AEB is similar to triangle ADC according to angle similarity rule. And from the fact that the two right triangles are similar to each other, we will derive that AB over AD equals to AE over AC. AB is 5, AD is 3, AE is 2R, and AC is square root of 13. So 5 over 3 equals to 2R over square root of 13. We multiply the equation number 3 by square root of 13. We found out that 5 over 3 times square root of 13 equals to 2R. We divided this equation by 2 and found out that the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 14 units, or in terms of numbers it is a little bit greater than 3 units. So we finish with the second method. Then I presented to you the third method. In the third method, we defined angle ABC as theta, and I presented to you a new formula. We have here triangle ABC, side AB equals to A units, side AC equals to B units, and the angle between side AB and side AC is theta. Then the area of this triangle ABC will be equal to A times B times sinus theta over 2. Okay, so according to this formula, we get that the area of our triangle ABC will be equal to AB times BC times sinus theta over 2. AB times BC times sinus theta over 2. And we know that the area of triangle ABC is 9 square units, so we substituted the area of triangle ABC by 9. So we got that 9 equals to AB is 5, BC is 6, times sinus theta over 2. So 9 equals to 5 times 6 times sinus theta over 2. 5 times 6 is 30, and 30 over 2 is 15. So in conclusion, we found out that 9 equals to 15 times sinus theta. We divided we divided this equation by 3. So 9 over 3 is 3 and 15 over 3 is 5. So in conclusion, we found out that according to equation number 1, 5 times sinus theta equals to 3. We divided this equation by 5 and we found out that sinus theta equals to 3/5. Sinus theta equals to 3/5, and we have the trigonometric identity that cosine theta equals to 1 minus sinus square theta. So cosine theta equals to 1 minus sinus square theta. Sinus theta equals to 3/5, so sinus square theta will be equal to 9 over 25. So cosine theta equals to the square root of 1 minus 9 over 25. We multiplied 1 by 25 and then we divided by 25 in order to have a common factor with this expression. So we got that cosine theta equals to 25 minus 9 over 25. So cosine theta equals to 25 minus 9 is 16 over 25. Cosine theta equals to the square root of 16 over 25. So here, cosine theta equals to the square root of 16, that is 4, over square root of 25, that is 5. So in conclusion, we found out that cosine theta equals to 4/5. Then I presented to you the law of cosines and we implemented the law of cosines in our triangle ABC. So here we have triangle ABC that could be any triangle. The angle between side AB and side AC is theta. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units. Then cosine theta equals to A square plus B square minus C square over 2 times AB times AC. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. We implemented the law of cosines in our triangle ABC. According to the law of cosines in our triangle ABC, cosine theta will be equal to AB square plus BC square minus AC square over 2 times AB times BC. Again, cosine theta equals to AB square plus BC square minus AC square over 2 times AB times AC. We already found out that cosine theta equals to 4/5. Here, so we substituted cosine theta by 4/5 and found out that 4/5 equals to AB square. AB is 5, so AB square is 5 square, that is 25, minus BC square. BC is 6, so BC square is 6 square, that's 36, minus AC square, over 2 times AB is 5 and BC is 6. So 4/5 equals to 25 plus 36 is 61, minus AC square, over 2 times 5 times 6 is 30, and 30 times 2 is 60. We multiplied this equation by 60 and found out that 60 over 5 is 12 and 12 times 4 is 48. So 48 equals to 61 minus AC square. We added AC square to this equation and subtracted 48 simultaneously and found out that AC square equals to 13. We took out of this equation and found out that AC equals to the square root of 13 units. Okay? Then I presented to you a new formula, and according to this formula we can find out the radius of any circle that blocks triangle. In our case, this circle blocks triangle ABC. So the radius of this circle, according to the new formula, will be equal to the multiplication of the sides of the triangle by each other. In this case, it is AB times AC times BC over 4 times the area of this triangle ABC that is blocked by the circle. So here, so it is R equals to AB times AC plus times BD over 4 times the area of triangle ABC. AB is 5, AC is square root of 13, and BD is 6 over 4 times the area of triangle ABC. The area of triangle ABC is 9. So it is 4 times 9. R equals to 5 times 6 is 30, so it is 30 times square root of 13, over 4 times 9 is 36. We divided both the numerator and the denominator of this side of the equation by 6 and found out that 30 over 6 is 5 and 36 over 6 is 6. So in conclusion, we found out that the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, the radius of this circle equals to a little bit, it is a little bit greater than 3 units. Okay, so in all 4 methods we found, we arrived to the same result, that the radius of this circle equals to either 5 over 6 times square root of 13 units, so in terms of numbers, it is a little bit greater than 3 units. Okay, thank you very much.